Hello students, today we will do some numericals based upon center of gravity and principle of movements. Let us take first example of numerical. A metal bar 70 centimeter long and 4 kilogram mass is supported at two knife edges placed 10 centimeter from each end of the rod. A 6 kilogram load is suspended at 30 centimeter from one end. Find reactions at the knife edges. Solution. See in the given figure, AB is the given rod which has the length 70 centimeter. The distance is AK1 is equals to distance BK1 is equals to 10 centimeter, as the both knife edges K1 and K2 are placed at 10 centimeter far from the both of the end of the rod. A weight of 6 kg is placed at point P, which is 30 centimeter far from the end A. So here the distance AP is equals to 30 centimeter, where the weight 6 kilogram is placed suspended at the point P. The distance AG is equals to 70 divided by 2 is equals to 35 centimeter, because the G is that point where the center of gravity or the center of mass of the rod exists, and its position is at the center of the length of the rod. So G is the middle point of length AB, and that's why the AG is equals to distance BG also, and that is equals to half of the rod length, 35 centimeter. The rod AB is in equilibrium. So for translatory equilibrium, of rod AB, the sum of reactions is balanced by the two weights, means the two forces acting in opposite direction of the reaction. That is the sum of weight suspended at point P and weight of the rod acting at its center of gravity, which we can write further as R1 plus R2 The reactions R1 plus R2 will be equals to weight at point P plus weight at point G. The weight at point P is 6G and the weight at point G is 4G, where G is the gravitational acceleration. Further, it gives the value of R1 and R2. The sum of R1 and R2 equals to 10G equals to 10 multiplied 9.8 or R1 plus R2 equals to 98. Let us consider this as equation number 1. Now since the rod is also in rotational equilibrium, so for rotational equilibrium of the rod, the moment of R1 and WP with respect to G point is anticlockwise. The moment of R1 with respect to center of gravity G is negative and the moment of R2 and weight suspended at point P with respect to point G is positive. The moment of weight of rod acting at G with respect to G is 0. So positive moment is equals to negative moment, which we are taking here with respect to point G. So we can write here the moment of reaction force R1 with respect to point G equals to R1 multiply K1G, that is positive moment, is equals to R2 multiply K2G plus WP multiply PG. As we know the values, so it will be R1 multiply K1G as AG minus AK1 equals to R2 multiply K2G, which is equals to BG minus K2B plus WP multiply PG, which is equals to AG minus AP. It further gives us the result R1 multiply 35 minus 10 is equals to R2 multiply 35 minus 10 plus 6G multiply 35 minus 30. So it gives us 25 R1 is equals to 25 R2 plus 30G, or R1 minus R2 is equals to 30 upon 25G, or R1 minus R2 is equals to 1.2 multiply 9.8, or R1 minus R2 is equals to 11.76. Let us consider this as equation number 2. By solving both equations 1 and 2, we get R1 equals to 54.88 Newton and R2 equals to 43.12 Newton. This is the required answer. So that's all for today. We will discuss the next topic in our next one. Till then, good day.